Welcome to the Analytics Engineering Podcast, featuring conversations with practitioners inventing the future of analytics engineering. Today, I'm speaking with Erik Bernhardsson, CEO and co-founder of Modal. It's Erik's second time on the podcast, and our conversations are always fun. Erik is not afraid to go deep or to voice strong and sometimes spicy opinions. We talk about everything from Gen AI and the shortage of GPUs, to the future of cloud and egress fees, to whether or not the job title data engineer is something we should want more or less of in the future. The whole hour is packed with insights and was a ton of fun to record. Without further ado, let's get into it. Erik, welcome back on the Analytics Engineering Podcast.
Thank you. It's a great pleasure to be here. It's been a while.
Yes, I think you might be only the second person who is a repeat guest. The other one is the one and only Ben Stansel. I think you were on during, season 1. And back then, you were still in, stealth mode with the project that has become now Modal. Do you want to give us an update on what you've been up to in the last few years?
Yeah. I remember when we talked. It was the depths of COVID. I just quit my job and I was kind of hacking on something that's now sort of turned into Modal. And back then, my sort of idea was I wanted to build a general purpose platform for running compute in the cloud, and in particular, like focus a lot on data, AI, machine learning use cases. I'm still working on that. So 3 years later, I'm still working on that. I think a big sort of change, not a change necessarily, but like what we discovered along the way was AI and Gen AI is a great application. So because when we started building this, and it was initially just me, and I think back when we talked, it was just me, and now we're 25. But when I started building this, I didn't have like a clear use case in mind. I just had an idea that like if I build this platform, people will use it because it seems like a gap in the market. Turned out that Gen AI is a killer app for what we built. We've seen a lot of traction running some pretty large scale application around audio, video, image, like various diffusion models, also some sort of various biotech models, video processing. So we run a big compute cloud, big pool of GPUs, CPUs in the cloud. And then the sort of other side of that is we offer an easy to use Python SDK that makes it very nice, very easy to take code and deploy it into the cloud, and in a way where you don't have to think about scaling and provisioning and containers and all that stuff that typically you have to do if you build your own stack.
So there's a million things to get into there. Everyone that listens to this, I think, is going to be pretty familiar with services like Snowflake or Databricks. And there's a way in which you are familiar. You're similar to those services, which is to say that you are building a compute platform that is built on top of the cloud providers. And so the way that I think about this is that they're the physical clouds and then there's the logical clouds or the software clouds.
Yeah.
And so like AWS, GCP, and Azure, they like actually buy CPUs and they stick them in data centers, and that's like a part of their competitive advantage is like they can spend that level of CapEx. For Databricks and Snowflake, they are selling essentially like compute capabilities that you are proprietary, that you couldn't access outside of their context. Like, why do people need Modal? Like, how is it different than like just operating directly in the services that like AWS provides?
Yeah, it's a great question. I wrote a long blog post about this a few years ago, and I sort of at a very high level, I think that there is more room in the sort of cloud space, and I think AWS and GCP and Oracle and Azure and all of these, Alibaba Cloud, whatever. They've done a fantastic job like building the sort of foundational layer of storage and compute. And starting back in 2006, 2007, I've used AWS for, I think, a good 15 years, right? And I love AWS for what it enables me to build. But it's still not easy to use. And it still, gets in the way of like iterating quickly, deploying things, like shipping things. And so I think AWS has like a very solid place in that stack where, they're an amazing compute and storage provider, and they have a few other high level services that are really good. Route 53, RDS, and a few other ones. But I think there's plenty of room to innovate in the layer above, which I think of as the sort of layer that you were talking about, which is the Snowflake layer. Vercel, maybe another example, Fly, Railway. And that's also where I would put Modal, right? Like Modal, we don't own physical hardware, but we sort of repackage a lot of the cloud primitives in a way that suits what data, AI, machine learning teams want to accomplish. And by doing that, focusing on one particular use case, we can offer a much better user experience.
I don't think I would be saying anything that anybody at AWS would disagree with here, but when I hear product launch announcements and public communications from AWS, they often, like, the way you accomplish X thing on it, specifically data things in AWS, is often you like use this service with this service with this service, and actually maybe you're lucky if you only have to use 3 services together. Is the thing that you're trying to do to like think kind of cohesively about a persona and ask what is the thing that they need to do in the cloud and provide them like a simple API? Is that a way to think about that?
Yeah, I think that's a way to think about it, and I think that's also a way to think about like why AWS and all the other cloud providers are hard to use. Is that they try to build a sort of for every user at the same time, which means no user is going to have a good user experience. At the end of the day, they're massively successful businesses generating tons of money from storage and compute. That's where I think they belong. Like that's like the core part of the stack. Anything above that, I almost feel like, of course, like AWS is going to try to drive, usage of storage and compute by like building higher level services. But I don't necessarily think that's existential to them in the same way. Like it's almost like they just want to drive demand to the underlying services. And you've seen this with the success of Snowflake. Snowflake, builds on top of AWS and the other clouds, and in a way competes with them, but not really, because at the end of the day, like AWS and the other clouds, like they get the money either way. And so I think this is sort of an interesting sort of, I don't know, like you used to have more like vertically integrated clouds, but actually like you're starting to see like a bit of a segmentation where like I think AWS is going to do really well at the lower level, but the higher level, I think there's so much room to build amazing developer experience, just like yourselves, by the way. And I think in many cases, I wonder if like individual software engineers in 10 years or even in 5 years, if they're ever going to think about the cloud in the same way. Like that might be kind of abstracted away from a lot of people.
Yeah. So, okay, there's room for a layer on top of the hyperscalers, and Databricks and Snowflake are both sitting in that place today, and you're kind of a more nascent entrant there. How do I frame the thing that you're helping users out with versus the thing that a Databricks would? I say especially Databricks because I think that they're very focused on AI use cases as well and have a lot of mind share in that developer community. And that seems to be, you're doing a lot of work there too.
I sort of hesitate to like, position ourselves against Databricks because in many ways, like they're a fantastic company, also a Swedish CEO, which I like. But, I think, aspirationally, I think we share the same vision of like what we want to accomplish. They're obviously like, massively ahead of us by 10, 15 years. Like they raised like a Series H or whatever most recently. But yeah, like I think their vision is the same. Like they want to build an end-to-end platform to serve data, AI, machine learning needs, right? Like I think we come at it with a very different architectural approach, which is like we went all in on the cloud. We basically said, you can't run this yourself. We're going to be not just the software layer, we're also going to be a hosted infrastructure as a service platform. So I think building for containerization, building for cloud, building for this like, multi-tenant, super elastic compute pool, I think that meant that we could make very different sort of architectural decisions, which, obviously biased, but I think we have the right tailwinds. So I think that makes us quite different, right? Like we're like thinking about architecture in a very different way.
There's a whole trend going on. I do a bunch of angel investing, and I've seen a couple of companies recently that are doing some version of helping you abstract away the kind of fundamental cloud primitive, I think anytime you use any of the hyperscalers, first you have to make a decision like which hyperscaler am I going to use for this particular thing, and then two, you have to ask which availability zone region am I going to locate in. And that didn't seem to be like very constraining when you were just like doing web app development or whatever, but it is increasingly constraining today. And so these services seem to be allowing you to have like this abstraction layer across the different hyperscalers and across the different availability zones to do kind of resource pooling and stuff like that.
Yeah.
Why is that happening today? Why do people care about that today?
I honestly think it just comes down to the fact that GPUs are expensive.
Okay.
So because GPUs are expensive, in order to, make the economics work, you have to run them at very high utilization. Because you run them at very high utilization, you're going to have poor availability, which means that for any single availability zone, you may actually be close to capacity most of the time, which means in order to do this well, you need to go to different AZs, you're going to need to go to different regions, you need to go to different clouds. So it's a big part of what we've been spending time on is integrating with a bunch of different cloud vendors, using all the different regions and zones, and then just getting capacity to the customer wherever we can find capacity. That's actually a kind of a fun, interesting problem in itself. We monitor prices, which that change dynamically 24/7. We solve a mixed integer programming problem to figure out the optimal placement, given the resource constraints. How do we allocate the pool of machines in the cheapest possible way?
Okay.
So this is kind of a fun, interesting thing.
Can you educate me more on this? So there's a fixed number of GPUs in the world. There's fewer GPUs than the number of workloads that. And just for listeners, we started the podcast and Erik was drinking a La Colombe double shot out of a can. And now he's already switched over to a Red Bull. We're only 10 minutes in and he's already on his second.
I'm tired this morning. I just needed a little extra energy.
So there's fewer GPUs than workloads in the world, I think. Is that a true statement?
Yeah, I mean, I think the sort of fundamental economics of GPUs is that most of the cost goes to NVIDIA. So in order to recoup that cost, you need to run them at very high utilization. Unlike CPUs, by the way, most of the CPU cost is actually power, which means that it's more of a variable cost, which means that actually you don't really care about utilization of CPUs as much. So AWS could just over provision and run things at much lower utilization. But GPUs, in order to make the economics work, you need to run it at high utilization, and that changes a little bit. I mean, hopefully GPU prices will come down. That's what I'm hoping for. But right now, it is a supply-demand problem.
Let's say that somehow, and maybe that's an interesting question too, but let's get there in a second. Somehow GPU prices come down over time and they become more like x86 processors in the way that the market works. Do we still care about this hard work that you're doing to combine resource pools of GPUs across multiple availability zones, or is that work just kind of throwaway when GPU prices go down?
I mean, maybe. I think it becomes less relevant. On the other hand, I think the value of the platform then becomes more important. I think a lot about this. For a lot of AI startups, are you long GPU prices or are you short GPU prices, right?
That's interesting.
If GPU prices go up, what happens to the value of your company? Or does it go up? I think the truth is, if GPU prices were to crash, it would be hard for us in the short term because we have a bunch of long-term contracts with, and the revenue would go down quicker. But I actually think in the long run, it would be good for us. Because I think having an abundance of GPUs, I mean, first of all, it's very good for customers, right? It's good for the world. But I also think, for a lot of infrastructure provider, in a way, the main, we focus on the software, not the hardware. And the relative value of the software versus the hardware, if the underlying cost of the hardware goes down, the relative value of the software goes up, right? So I don't know, maybe I'm rationalizing it.
That's interesting. Yeah. Okay. Now, again, this is not exactly the thing that you work on, but maybe I can ask you to prognosticate here. I'm curious what you think is the most likely way that we might see GPU prices fall, if they do. I am not an AI engineer, and maybe we can talk later about what does that even mean. But I asked a very, very smart person that is deeply involved in building out Meta's GPU infrastructure how they felt NVIDIA's lock on the GPU ecosystem was relative to the Wintel lock on computers back in the 90s. And his answer was it's bigger. Their strategic mode is bigger than the Intel mode back in the 90s. And so that's an answer I take pretty seriously.
Yeah, I think to answer where GPU prices are going, there's two big factors to me. One is the one you said, right? What is the moat of NVIDIA, and why? What happens if another supplier starts to gain market share? The other question is just supply demand. So on the first one, NVIDIA versus other suppliers, like in particular AMD, I think is the main one, but also like TPUs in GCP, and AWS has Inferentia and Trainium, so they have also their own custom chips. I mean, NVIDIA has like almost like effectively 100% market share in my opinion, right? Like, and like I've been saying every year, like this is going to be the year of like non-NVIDIA accelerators, and it hasn't happened. And I've been saying that for.
Does Modal use anything but NVIDIA GPUs?
Not right now. No, we've actually tried Inferentia and we've tried TPUs. A lot of it just comes down to like what our users want, and there's not a lot of users asking for that. We've actually seen a little bit more users asking for TPUs recently. Part of that is like the software stack hasn't really been mature for like these alternative accelerators. But Google with JAX and TensorFlow actually has made TPUs like relatively easy to use and relatively cost effective. So for that reason, I think TPUs are actually starting to be like pretty competitive. Hopefully, one day we'll also see the same thing with AMD. Like I think this, the world would benefit from more competition. I wouldn't hold my breath. I think it's going to take a couple of years at least. But I also don't think it's sustainable for NVIDIA to have such high profit margins and market share.
Yeah, any moat is crossable with when you get into the trillions of dollars of market cap. Like,
yeah, and you look at Intel, right? Like AMD came and ARM and like all these things, right? So Intel is not nowhere near a monopoly anymore, right? The other side of it is like supply demand, and I definitely think for the last 2 years or so, like supply has been much lower than demand, right? Like demand has been growing much faster than supply, right? Like driven by, in particular, like big whales like Meta and the cloud providers like buying insane amounts of chips. That seems to continue. That being said, I feel like there's less excitement from the VC side, like putting billions of dollars into like just buying NVIDIA chips and these types of things. I see a lot of startups.
We did that for like a year as an industry, and then it didn't go that well.
We did that, yeah. And there's this sort of idea, like you train a foundation model, and then you have like enormous gross margins on the inference. Like I don't know if that necessarily materialized. And I'm actually seeing sort of a lot of startups like now trying to resell very big GPU allocations. So I'm starting to feel like at least in the startup space, like there's less to sort of GPU hoarding going on. Meta is still buying an insane amount of chips. Elon Musk seems to want to buy an insane amount of chips. So I don't know, like demand seems to be pretty strong so far still, but I give it a couple of years. I think that's gonna like balance out, I think, a little bit more.
Do you have any sense of if you take the market for GPUs that is the 3 or 5 hyperscalers? Because they're fundamentally like buying these GPUs to rent out to other people.
Yeah.
Versus the people who are buying GPUs like Meta to like use in their own data centers. You have any idea of the split there?
I think it's like quasi-public information. I feel like Semi-Analysis, one of those like newsletters probably has like some breakdown of that.
Semi-Analysis is one of those newsletters that I read up to the free line, and then it gets real deep real quick.
Yeah, it's very expensive, and it's like 200 pages every week. So I kind of casually glance through it, but it's interesting.
Okay, let's talk about egress fees. There's one of the driving forces of being cross-cloud, cross-availability zone is GPUs. And then in the past, one of the reasons not to do that had been that it's just like really expensive to move your data around.
Yeah.
I think in certain cases that's still true, but it's starting to change. Can you say more about what's happening with egress fees?
I mean, I don't know. Like, I think AWS still has very high egress fees, and but they're coming down. I think there's a lot of pressure from R2 and Cloudflare, for instance, and GCP has lower, and other cloud providers. The interesting thing about Gen AI is like egress fees doesn't really matter that much, and I think that's been kind of a weird sort of re-architecture of a lot of compute. I think part of like why we've been able to build like a multi-region, multi-cloud architecture is that if you think about it, like Gen AI is actually very like bandwidth, like not, it doesn't need a lot of bandwidth. It's very compute hungry. But like if you think about like Stable Diffusion, you send it like a text snippet and then it runs like trillions of operations, and then it comes and then it sends like 100 kilobytes of JPEG back or PNG or whatever, right? So like the bandwidth data is actually very little compared to the compute. So in many cases, like
for the inference part,
right? And so, yeah, training is very different. Training, like you need like very hungry inference. So those you need to run in the same region, or same zone even. But just to hang on for a second on the inference side. So also inference is kind of slow. Like it takes like, a few hundred milliseconds typically at least, right? A little bit less for like LM, like streaming LM. But what that means is like actually like the latency is not that super critical versus everything else. So it's totally fine in many cases to run, rent a GPU in like Australia, if that's the cheapest price, today, and then send the traffic to Australia, run a bunch of stuff in Australia, and take the data back. So I think for Gen AI, it's been kind of in this like weird zone where like, but then like people starting to do more real time stuff. They start getting more like latency sensitive, etc. I think you're talking about it like a little, maybe like alluding to like more like sort of data warehouse applications,
Yeah,
like that
data
kind of stuff.
workloads tend to be very egress fee sensitive.
They tend, yeah, and I think for that reason, historically, there's been a lot of sort of what I think was like data gravity. Like once you have your data in a particular region, you rarely want to run stuff outside. I mean, I think in theory, like over time, like egress fees will come down. I think more people will maybe put stuff on R2. Like we built our own file system based on R2 for the reasons that they don't charge egress fees, right? And they also do like geographical distribution, all this cool stuff. So I don't know. Like again, like it's a kind of a similar thing. I wouldn't hold my breath, but like I have a feeling like over time egress fees will come down, and the sort of region distinction will matter less and less, except for like latency sensitive applications. But like it turns out like a lot of stuff is actually not that latency sensitive.
One of the, I think, biggest conversations in the data industry today is what's going on in the file format catalog wars, Unity, Iceberg, Delta, etc.
Yeah.
And there's a lot of focus on making sure that my different systems can talk to each other, both read and write. And that's great. But I feel like one of the things that we're not talking about yet is that inevitably, if you have a global company, you're probably not using a single cloud provider in a single availability zone. So you also have to solve this kind of fabric issue where is the data physically located?
Yeah, that seems
it's not just a format thing.
Yeah.
Okay, let's go from the future of the cloud to the future of data engineering. You've been involved in data engineering. We've been talking about Gen AI and GPUs for the past little while, but you spent a long time as a data engineer or just building tooling for data engineers?
Sort of. Like, and maybe I could have given my background. Like, I was at Spotify for 7 years. I built a lot of music recommendation system, and then I was at a company called Better for many years as a CTO. I think I always like been like focused on like data, AI, machine learning, like and then like the precursor to all of that, or like the prerequisite is like you got to get to data. And so that sort of necessitates doing a lot of like data engineering, data cleaning, building data pipelines. Like I ended up building my own like workflow scheduler at some point called Luigi, like no one uses it today, but sort of like Airflow. And I spent a lot of time in that space.
Today, but you're skipping by a time period in which a lot of people used it.
A lot of people used it like 10 years ago. So I was deep in that swamp. Data engineering is like funny because like in a way, like I kind of don't want it to exist. And that's like sort of, my prediction has always been like, I don't think data engineering should exist. And I think it's going to go away at some point, but it sort of still exists. So,
okay. I want to explore this with you because in many ways, I agree with you. At the same time, there's a ton of humans in the world that call themselves data engineers that use DBT. And so the last thing in the world I want to do is like say, I think data engineers suck, because I actually don't believe that. The funny thing though is that technology progresses over time and the jobs to be done that humans need to do change. And so I think that if you went back to like 2003 and you told somebody with a webmaster title that like, we don't need that title anymore because now we have content management systems and like the users actually just interact directly with the CMS and they just like make the changes to the website.
Or DBA is like another role that like completely went away.
So it's clearly data engineering needs to happen. It is a question of like, how many humans do we need involved in the like, and I think that in 12, 15, the systems that we had access to required a lot of like tinkering and dials and adjusting and that kind of stuff. And so you needed real humans to maintain them. Now I think it's a little bit less than it used to be. Is that?
It's less. It's going down. Yeah. But I still think, I've seen this so many times, like, a team of data scientists like benefiting tremendously from just like injecting a lot of like data engineering skills. Because suddenly they can get the data, they can like, productionize workflows, like, So like I still think it's like it is de facto needed, and it provides enormous amounts of value. But like the question is like why, right? Like in a way, like I don't really like the idea of like someone whose job is just to shuffle data around. Like I want everyone to think about what does the business need and build business applications, right? And like I would say the same thing about any sort of internal platform team. Like I don't, I think it's like, de facto they're needed. Like we need people at most companies that maintain the internal platforms. But to me, those are always like sort of transient technologies that will go away over time. because we should just buy vendors and we should
Or
just
use open source tools that
or use open
abstract
source
it away
tools.
from you.
Exactly. Right. And so all these like internal platform teams, I think tend to be like somewhat ephemeral and transient. And like over time, I think they're always going to be new to, hopefully my hope is like a lot of that goes away. All these titles too, right? There's data engineers, data scientists, analytics engineers. Like to me, it's like, it doesn't matter. Like there's always going to be people who need to work with data, AI, machine learning stuff, and like, I think that's like very constant. And that slice is going to, that's going to grow and grow and grow. But the actual like composition of those teams, I think, is going to change a lot. And so I don't really pay that much attention to titles. I don't know.
Yeah.
Maybe you do.
No, it's funny. Back in 2016, 17, 18, where we were just kind of getting started with DBT and the DBT community, we thought a lot about titles, partially because one of the biggest indicators of somebody who was going to say, no, I don't need that, was like they had a title of data engineer, because they were like, look, I want to use Spark, and my career development plan says next I will use Scala with Spark instead of Python with Spark, and like that's me developing.
Yeah.
And so you're telling me to go backwards and use SQL. And so we developed this little kind of hybrid role, the analytics engineer, like mostly people who considered themselves data analysts who like wanted to self-serve more, whatever.
Yeah.
Over time, all of this stuff has gotten like so blurry that I actually find that focusing on the titles, like you're saying, actually obfuscates rather than helps. Like I just put the finishing touches on my draft of this white paper that I'm calling the analytics development lifecycle. And I think that there's 3 different jobs to be done in the analytics development lifecycle. There's a developer, like people who create reusable assets for other people. There's an analyst, like people who actually like interact with the data to try to draw conclusions about the real world. And then 3, there's a decision maker, like people who actually like get the recommendations from the analyst and like actually go and make decisions. Anyway, if you start slicing it up more than that, I think you actually inject friction into the process as opposed to add clarity.
I think that's right. And by the way, I have to compliment you on that like marketing move of like putting that label analytics engineer, because I think at that time there was like so many people out there and they were like a little unsure, like who am I? How do I fit into the greater organization? And I think you brought them an identity. Like you created this like almost like a movement around that, like people suddenly feeling like, oh, I'm an analytics engineer. This makes sense. And I think that was like eye-opening for so many people and created a sense of belonging in a community. So that was brilliant.
Thank you. Yeah, it was my favorite thing was when people told me that they got an analytics engineer title and their pay went up 50%. I was like,
yeah,
great. But you're doing valuable work. You should be paid for it.
Yeah, I think you gave a lot of people a lot of recognition, and I think that you should get a lot of credit for that.
Okay, so we've talked about data engineering as a valuable thing to be done. There's a trajectory here where probably fewer humans need to turn knobs and dials. What about machine learning and AI? So there's ML engineers. More and more, there are people describing themselves as AI engineers. Do we need specific titles for these things, or are we all just software engineers?
To me, the difference between AI engineer and machine learning engineer is that AI engineers use TypeScript and machine learning engineers, they use Python for the large part. I kind of feel like a lot of the like recent stuff around like LLMs and stuff, I think of it as like, not to sort of trivialize it, but like it's like a low code machine learning tool, right? Like a lot of people for which, machine learning felt unapproachable, suddenly they were given a new tool and they realized like, oh, I can like just, stitch this together with, a bunch of prompt engineering and get it to work. And actually like a lot of them use Python. So it's a little bit silly distinction maybe. But I think there was a lot of people for which like machine learning and AI was inaccessible that now it is accessible. I think there's also a lot of stuff like, a lot of people in the sort of traditional machine learning world, that's not going away in my opinion. Like I think, some of it will be replaced with LMs, some of it will not.
We're still going to do fraud detection algorithms, and your LLM is not going to do it.
Yeah, we're going to do computer vision. We're going to do, my experience is like, when there's like new technologies, for some reason people always think about, oh, like the size of the pie is fixed. Like this new thing is going to take over all this other stuff. Always ends up turning out as like all the slices of the pie grow. So like, I think we're going to need more AI engineers. I think we're going to need more ML engineers. There's going to be a lot of high code tools. There's going to be a lot of low code and a lot of no code tools. It's all going to grow.
My read on this, and you probably have a better one, but is that building AI systems is more accessible to people who would have traditionally called themselves software engineers than the jobs of an ML engineer, like building a fraud detection algorithm. And I think that is because the LLM APIs are very good, and you don't actually need this entirely quantitative skill set that ML engineers really did. Is that an accurate read?
I think that's right. I think it's very similar to like what I think of as like traditional data scientists versus analytics engineers. It turned out like analytics engineers could get a lot of stuff done, and it was a very different role than sort of what we think of as like data science, which is like you need to know statistics, you need to know t-tests, like whatever, and it turns out like, suddenly there's like 10,000, 100,000, whatever analytics engineers. But I don't think the data scientists went away.
Mm-hmm.
They still are needed. People just didn't talk about it for a few years. But they're still needed, and they're still, I think, thriving.
Let's say that you're at a traditional software company. Your product historically has been built and maintained by primarily people who you would consider to be full stack software engineers, and you've got some infrastructure engineers. They're like a pretty classic engineering team makeup. And now your customers are asking for AI experiences in the product.
Yeah.
What's your first step? Do you need to go and hire a bunch of AI engineers, or do you need to turn your existing engineers loose on OpenAI APIs?
I think a lot of companies can do a lot of stuff with the OpenAI APIs, right? I still think a lot of those companies will hire machine learning engineers eventually, because that's a different set of things you can build with those. And I don't think it's like necessarily a big overlap. If I think about, Spotify, for instance, like I spend a lot of time building our music recommendation system. Like an LLM can't do that because the LLM needs to operate, like fundamentally it's like a very large proprietary data set that we needed to train our own models on. But certainly Spotify could now use LLMs for a bunch of other stuff, like, I don't know, like extracting sentiment from music lyrics or whatever. But yeah, like to your point, right? Like, and I see there's a lot. Notion building all these like cool AI features that are all just, LLM powered and just operate on the documents, right? Or what's another good example? Like all these email autocomplete, or LinkedIn. Actually, LinkedIn is a bad example because I always find that they're like the responses are kind of funny, but like
I feel like they're not loading up any context from any of the prior messages.
Yeah.
I'm just like, this is not insightful at all.
Yeah, I like the buttons because they're always like, great job. Like, and I always want to press them, but I don't think anyone does.
Yeah, they're clearly trying to nudge the behavior on the platform towards positivity and not negativity. LinkedIn has become like the place where we all high five each other.
That is true. Yeah, whereas Twitter is the opposite.
Right. Yeah.
What's the opposite of a high five?
Punch in the stomach. I don't know.
Yeah.
We're both engaged in doing a similar thing. We're both building dev tools. We took a particular approach, which is sometimes the approach taken is very open source and organic and community driven. I don't think Modal has an open source component. Is that right?
No, our client is open source by necessity because it's like a piece of Python code that people need to install. But everything else is closed source.
So certainly, like many data tools have gone the open source route, like Airflow, and you could go down the list forever. But there are plenty of dev tools, GitHub, Twilio, Datadog, etc., that aren't open source and have never been, but they have grown these like massive followings of users. What are you learning about the playbook of how to build that kind of community?
It is harder for us. And like maybe like one way I think about like all of this stuff is like 10, 15 years ago, like open source was probably like the only distribution mechanism for code or like for software, right? Because people ran stuff on-prem and there was no such thing as like SaaS or infrastructure as a service and stuff like that, right? And so the only way to sell software in many cases, it wasn't like the only, but like the main way to like distribute software, I think, was to build an open source thing that people can install. Today, like I feel like people are so kind of used to using the cloud and using vendors, and like even like things like Snowflake or Fivetran and all these things. So like I think there's like it's like two different business models that both clearly make sense for different types of companies. I actually don't know which one makes sense like the most, right? Like you obviously took a open source approach, which I think as like I think can drive a lot more adoption. It can drive much more reach, but with the flip side that it can be harder to sort of then monetize it because those people will just run it on their own, self-hosted, right? Whereas like I took a different approach, which is like we run everything in our cloud, which will mean that monetization comes easily. It's like very natural. People run code on Modal, we charge them for it. However, that is an approach that I think is a little bit harder to sell. It takes longer for adoptions because people can't. A lot of people want to self-host. A lot of people want to install it in their own. Maybe it's like security compliance
Do you
stuff.
get
Like they
those
want
kind of
to
requests?
all the time. And right now, we made a business decision to say, okay, sorry, Modal may not be your product. In the future, maybe we'll have more like flexible deployment models, whatever. I look a lot at Snowflake as a sort of, I think they paved the way and kind of showed that you can build. When Snowflake came, by the way, I thought it was crazy. Like, I'm like, why would I run like a database in the cloud? It doesn't make any sense. But on the other hand, when the cloud came, I also thought it was crazy. Like, why would I want to run my stuff on someone else's computer? So, like, I do think there is like a sort of a bigger arc of like people being more and more willing to use first the cloud, then like cloud vendors, and then hosted infrastructure. But yeah, like that changes thinking a lot of time. And like people still want to run. Previously used to be we want to run it on prem. Now it's like we want to run it in our AWS account, and it's the same challenge. Like we can't sell to those customers today. So yeah, that will take a long time to figure out, I think, for us.
Other than the like deployment model where it's run, do you have open source religionists that I don't want to tie myself to a commercial service. I want the control to be able to run this thing on my own if I need to.
Surprisingly little, because I hear the argument, right? Like some companies don't want to adopt a tool where like they're like, well, you're a startup. What if you go bankrupt? Then like then we can't run it ourselves, right? It's a come up, but actually I have been surprised that like it hasn't been like a big major sticking point selling Modal to companies.
We got into the different roles that all kind of roll up to software engineering in some way, but I forgot to touch on the role of the software engineer itself. I want to go back there. My experience so far of using copilots is mixed. Sometimes it's good. Sometimes it's like not that good. And I feel like it's a little bit like Tesla self-driving. I bought my first Tesla because I was excited about the self-driving. I was like, hell yeah, I'm going to push that button and I'm never going to drive again.
Yeah.
And then it turns out that I actually find it more stressful to monitor the self-driving than I do to just drive. I would rather just drive myself. How quickly do you think we're progressing down this path of the fundamental job of a software engineer changing because of AI?
Yeah. By the way, I also have a Tesla, and like I live in New York, and the self-driving is useless in New York.
Yeah.
Like it just we basically we've never used self-driving because like the few times we turn it on, it's just like it just wants to have this like enormous distance to the cars, and like it doesn't like it's just not an aggressive
Everyone in New
enough.
York is going to give you the finger.
Yeah, they just cut you off.
Yeah.
So anyway, so going back to your question, yeah, like I think AI will make software engineers more productive, and I think it will make it easier to write more software quickly. That is not different than any other than many other tools that we've gotten in the last 30 years as software engineers, whether it's compilers or scripting languages or various types of frameworks or cloud or greater IDEs and all these things, right? Or CI/CD, I think is like another paradigm shift. So I think to me, there's like so many things that happen to software engineers. If you take a software engineer and look at them like 30 years ago, I've been coding actually for roughly 30 years. I think like every decade, software engineers have become like, I don't know, 10x more productive. And maybe with AI, like that trend is going to continue. But also like the number of software engineers have grown by an order of magnitude every decade too. So like I think there's just so much latent demand for software engineering out there in the world that like, yes, like hopefully AI will make software engineers productive. Hopefully that will induce even more demand for software engineers because there's just so much bad software out there in the world that desperately need better software. And I think there's so much demand for doing that like if engineers become more productive, there's just going to be more of them needed. So I'm very bullish on software engineering.
You're an optimist.
I'm very optimistic.
Are you worried at all about and you could have the same kind of reaction where like back in the 70s, we wrote our own assembly and we were real programmers or whatever.
Right. And compilers, like, that's going to make engineers useless. You're going to have, that was actually, like, if you think about a COBOL, like the original pitch was like, you can write your code almost like as in English.
Right. So I'm certainly sympathetic to that, and I don't want to overstate this case, but I am aware of people that are in the like senior engineer track at large tech companies, and they see engineers graduating that are in the early stages of their career that over rely on the AI tool set. And the criticism is from these graybeards which I consider myself one of at this point, these kids, they don't write good code because they rely on this AI, and then the AI doesn't understand it, and then bad code gets incorporated into the. So what do you think about this trajectory?
I mean, I don't know, right? Like, I'm sure like 10, 20 years ago, they're like, oh, these kids, they don't write
Right.
C++. They don't understand how computers operate. It's all whatever. I'm fundamentally always, bullish on new technology. And I think people are going to, people are obviously going to go higher up in the stack, right? We don't write code at the same level we used to, 20 years ago. Like we write code higher up in the stack, and that's fine.
Yep. No, I'm with you. I'm totally with you. And I think it's not just about the set of people who actually call themselves software engineers gets bigger and is able to have more of an impact. It's also more types of people use these types of workflows. We're just now, and we announced, kind of like pre-announced this back in May, but we're working on a low code, no code visual editor for SQL for DBT models. And I am like fundamentally bullish that there's not like software engineers don't have a unique license on intelligence and being able to build systems. It's just that like as we continue to make the tools to do so more accessible, like more humans can participate in that process.
Totally. And just like using tools like Webflow or Wix or whatever, Squarespace, people now don't need to be front-end engineers to build a website. They can knock things out. And I think that or Shopify or whatever, right? Like people can build amazing stuff online with very little code. But that fundamentally doesn't remove the need for software engineers. Like they just go do some other stuff instead. So I think there's people benefit on both sides of this.
100%. Let's wrap with the question that I love to ask everyone. What do you hope will be true of the data AI software industry over the coming 5 years? Hope.
I hope that sort of somewhat self-serving, but I hope that people will never have to think about containers, infrastructure, provisioning, resource management. And I really hope that all of that will be abstracted away in the next 5-10 years. Like people will focus on application code and
business logic
and building cool AI shit, and then rely on infrastructure to providers like Modal to take care of all the other stuff.
Amazing. Erik, thanks for hanging out. This has been a lot of fun.
A lot of fun. Thank you so much.
The Analytics Engineering Podcast is sponsored by DBT Labs. I'm your host, Tristan Handy. Email us at podcast@dbtlabs.com with comments and guest suggestions. Our producers are Jeff Fox and Dan Poppy. If you enjoyed the show, drop us a review or share with a friend. Thanks for listening.